Um, Good. Hey guys, how you doing? So we'll continue on looking at sine, cosine, and tangent functions. And we did some of this in lesson 1. This is a repeat of the last example that from from the last lesson. And I did this example in an earlier video that was posted on Wednesday night or Friday or Monday. So you can find it there if you need help on this. It's an earlier video that I posted. The unit circle. A unit circle is a circle with a radius of 1 unit. Just like you hear it, the radius is 1 unit in all directions, right? And radius is any line from the center of the circle to the circumference of the circle. So all of those lines are 1 unit. That's why it's called the unit circle. In a unit circle, we can use a unit circle to find the ratios. Every time I say ratios, I mean sine, cosine, tangent of trig functions. Now, if you look at this unit circle and this angle theta that I have here, I can form a right angled triangle, and the length of this red line is going to be 1 unit because that's the radius. The x length from this position to this position, that's the x length because it's the x-axis. I don't know how long it is, but I'll just call it x. And this vertical height from here to here is y. So, so it happens that on a unit circle or in a unit circle, if I try to find the sine of the angle theta using our SOHCAHTOA, then the sine of the angle theta is going to be opposite out of hypotenuse, right? The hypotenuse is 1, the opposite is y. So I have y divided by 1. That's why in a unit circle, the sine of that angle is always going to be equal to the y value, right? If I think of this as an xy grid where I have x points and y points in a unit circle, the sine of any angle is always going to be equal to the y value of that point. So for example, the sine of the angle that makes this point is just going to be the y value from here to there in a unit circle. So the sine is y. What about the cosine? If I use the same idea, I have this triangle. This is x, that's 1. According to SOHCAHTOA, cosine of theta is adjacent divided by hypotenuse. So the adjacent in this case is x. The adjacent is x, and the hypotenuse is 1. So the cosine of any angle in a unit circle is always going to be equal to the x value of that point. What do I mean? If I have a point over here, right, the cosine of that angle that forms that point, and this time I'm counting counterclockwise, which is positive. The cosine of that angle is going to be equal to the x value of this point. The x value of this point is from here up to here, right? So that's a negative something. So the cosine of an angle will be equal to the x value of wherever the point is along the unit circle. So cosine is equal to x. What about tan? We know tan is equal to opposite over adjacent. So we know that tan of theta is equal to opposite over adjacent. And if I have again this triangle that right angle triangle that I make here, the opposite is y, the adjacent is x. So therefore the tan of theta is going to be equal to y divided by x. And this is true on a unit circle. Any point along the circle, the angle that that point makes with the center of that circle from counterclockwise from the positive x-axis, we consider this the positive x-axis. Counterclockwise, that angle is the tangent of that angle will always be equal to y divided by x. The y coordinate of that point divided by the x coordinate of that point. I hope you see that wherever I put the point will have an x coordinate and a y coordinate. Okay? And the x coordinate is the cosine of that angle. The y coordinate is the sine of that angle. And the ratio y divided by x is the tangent of that angle. We can also find exact values of trig functions using this idea. So for example, the angle pi out of 2 which is the same as 90 degrees. And if you need a shortcut to change radians to degrees properly, I mean quickly, so that you can easily deal with them, just remember that pi is the same thing as 180 degrees. So just everywhere you see pi, just plug in 180 degrees. So if I plug in 180 degrees for pi, that will just be 180 divided by 2, which is the same as 90. So I can even do this in my head without writing it out. I know that pi is 180, I plug it in there, and then I'll just have 90 degrees. So I know 90 degrees is along this vertical y-axis, right? 90 degrees is along this vertical line. So since this is 90 degrees, I can clearly see that this point up here has an x-coordinate of 0 because I have not moved along the x-axis. So the cosine, because I know the x-coordinate is the cosine in a unit circle, the cosine of that angle will be 0. What about the sine? This point has a y-coordinate of 1, and I know that the sine is the same thing as the y-coordinate. Just reminding you again, sine is y-coordinate, x is cosine, x-coordinate is cosine, and the ratio y over x is tan. So the sine of 90 degrees will be equal to the y-coordinate, and the y-coordinate for this point is 1 because the radius is 1. So the sine of 90 is 1. You can verify this with your calculators. The tangent I know is the ratio of y divided by x. So it's going to be 1 divided by 0, which is undefined, and that's why the tangent of 90 degrees is undefined. I mean, that's not exactly why. The exact reason is that in an angle, in a triangle, I explained this in class sometime. If the angle is, say, 60 degrees on a triangle, the tangent is something that's known, right? But as this angle gets bigger and bigger and bigger up to a point, I hope you can see that the adjacent keeps on getting smaller as the angle gets bigger, right? So now, if this adjacent is getting smaller, if it gets to this point where it's just straight vertical 90 degrees, the angle has got big enough so it's 90 degrees, the adjacent will not be existing. The adjacent will be non-existent. The adjacent will be 0. That's why the tangent of 90 degrees is undefined because we cannot divide by 0. But that was just a side note. Sticking to the main points, if I want to find the exact values of trig functions, remember pi is 180 degrees. When I see pi, I know that's 180. Then I just need to ask myself, where is 180 on the xy grid or the unit circle? 180 degrees, since this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then back here is 360. If I started at 0, then going there back would be 360. So 180 degrees is over here. The point is over here. Just ask yourself, what is the x-coordinate of that point? Well, this would be -1 because the unit is 1 in a unit circle. So -1 is my value for cosine. What is the y-coordinate of that point? Since I don't have any movement vertically, right? The y-coordinate of that point is 0. So the sine of 180 is 0. What about the tan? Tan is supposed to be y out of x, which is going to be 0 out of -1, and therefore the tan of 180 is also going to be 0. We can use this thinking to find the exact values of so many different functions. For example, 3 pi over 2. Now remember, everywhere you see pi, just plug in 180, right? Plug in 180. So 3 times 180 over 2 is the same thing as 180 times 1.5. So 180 times 1.5, is that 270? I think so. 270. Because 180 over 2 is 90, and 90 times 3 is 270. Yes, 270. Okay, so 270, ask yourself, where is 270 on this? You know this is 0, and when you come back, 360. And when you do another revolution, 720, and so on and so on. This is 90, this is 180, this is 270. If you look at that, 270 is the x-coordinate of 270 is 0, so the cosine is 0. The y-coordinate of 270 is -1, so the sine is -1, and tan will be y divided by x, which is undefined. What about 2 pi? 2 pi, if you multiply, if in place of pi you put 360, then again, put 180, then 2 pi is 360. I hope you can see x coordinate is 0, y coordinate, sorry, x coordinate is 1, not 0. Y coordinate is 0, and therefore tan will be sine over cos, which is also 0. Okay, so just to clarify, this is 0 and 360, and 360 is the same thing as 2 pi. This is 90 degrees, or something as pi over 2. This is 180 degrees, which is the same thing as pi, and this is 270 degrees, which is the same thing as 3 pi over 2. We talked about these special right triangles earlier, the one for 45 degrees and the one for 60 and 30 degrees. Oh, this angle is also 60 degrees. The one for 60 degrees is an equilateral triangle in which each side is 2 units. Since each side is 2 units and it's equilateral, then each angle is going to be 60 degrees. And when I cut this angle in half, then either side is 30 degrees because it's equilateral, and also either side is going to be 1 unit. If I do Pythagoras, I can find the height of this triangle as square root of 3. So from these triangles, we can get the trig ratios for each of these angles, 30, 60, and 45 degrees. And we did that in worksheet 5.1. I hope you guys remember. So I can use that idea to find the exact values of the trig functions for these angles. Now, pi over 4, please remember, every time you see pi, think of it as 180. Work out in your brain what's 180 divided by 4. If it's too hard, start by dividing by 2, that's 90. Divide again by 2, that's 45 degrees. So 45 degrees is going to be somewhere here, right? 45 degrees, 45 degrees. And I know that in a 45-degree triangle, this is square root 2, right? This is 1 unit, and this is also 1 unit. Because in a 45-degree triangle, the legs are both 1 unit, and that makes the hypotenuse square root 2. So, what is the sine? And remember, sine is the y value, right? The y value of that, the y coordinate of that point, and cosine is the x coordinate of that point. So, in the previous section, because here you'll be tempted to just go ahead and say sine of 45 is 1 and cosine of 45 is also 1, because it's just the x and y coordinates, right? This worked for the unit circle. This worked for the unit circle because the radius was 1 unit. Okay, the radius was 1 unit, and I hope you remember that we were dividing everything by 1. We're dividing everything by 1 because that was the radius. We kept dividing everything by 1. So here, this is not a unit circle because obviously the radius is not 1 unit. The radius is square root of 2. Okay? So a shortcut we can take is to just think, since we divided by 1 unit in the previous examples to get sine, because the radius was 1, here we can divide by whatever the radius is, in which case it's root 2. So therefore sine would be 1 over root 2, right? Because you're thinking of what's the y coordinate for sine? It shows me that this is 1 unit, right? And I divide that by the radius, which is root 2. Same thing for cosine. 1 divided by root 2. And for tan would be sine over cosine, which is 1 over root 2 divided by 1 over root 2, dividing by the same thing gives me 1. Okay? Some people do not like to leave this irrational expression with a radical or a square root in the denominator. So what they will do is they will multiply the numerator by root 2 and the denominator by root 2, which doesn't change the meaning because these can still cancel out to take you back to the same thing. But they do that just so you don't have a square root in the denominator and then it ends up being square root 2 divided by 2, which is something here, square root 2 divided by 2, which in this case this one is 1. Remember, how we got this is we divided the y coordinate, which was 1, by the radius, which was root 2. How we got cosine is we divided by the y coordinate, which is 1, by the radius, which is square root of 2. Okay? If you want, that was kind of the shortcut, but the real explanation is you go back to SOHCAHTOA, and then you use sine is opposite over hypotenuse. The opposite will be 1, hypotenuse will be root 2, will still give you the same exact answer. Okay, so those are the ratios for pi out of 4, which is the same as 45. 5 pi out of 6, remember, pi is 180. So where you see pi, put 180, do the division. 180 divided by 6 is 30 degrees. 30 times 5 is 150 degrees. So that's 150 degrees. 150 degrees is in this quadrant, somewhere here. But before I figure out what the ratios or the exact values of these figures for 150 are, I need to first find out what the reference angle for 150 is. The reference angle is this angle that it makes with the positive x-axis or with the x-axis. And I hope you can see that if this is 150 degrees, then I need 30 degrees left to make 180 degrees. So this reference angle is 30 degrees. Now, and I also hope you remember we talked about ASTC, all students take coffee, or whatever you want to call it. But these angles in all these other quadrants have the same ratios as their reference angles, except for the sines, and the sines are determined by the ASTC. So the angle 30 degrees in this quadrant will have the same ratios as another angle in any other quadrant that has the same reference angle 30 degrees. What I mean is 30 degrees is in this quadrant. If I'm going around in a circle, in this quadrant, 150 has the same reference angle, i.e. angle of the x-axis. In this quadrant, I think it is 210, which will have the same reference angle. And in this quadrant, it will be 330, which has the same angle of the x-axis, i.e. reference angle. Now, all of these angles, 150, 210, 330, and 30, have the same magnitudes, have the same exact ratios, except for the signs. The ratios for the 30 are the same as the ratios for 150 in this quadrant, except it's only sign that's positive. So using that knowledge, I'm going to find the ratios for 30 degrees. Then I'll just apply ASTC to find the ratios for 150. So for 30 degrees, going back to that 30-degree triangle where I had, where is the 30-degree triangle? Oops. This one, yeah. In a 30-degree triangle, I hope you remember, you can see that the opposite is 1, the hypotenuse is 2, the height is square root of 3. Going back to where I was. Where was I? There we are. Okay. The opposite in a 30-degree triangle is 1. The hypotenuse has to be 2, and the height, which is over here, is square root of 3. So I hope you can see that the sine of 30 is a half. Since the sine of 30 is 1 out of 2, the sine of 150 also has to be 1 out of 2. I just need to check whether sine is positive in that quadrant. Yes. The cosine of 30 is root 3 divided by 2. The cosine of 150 also has to be root 3 divided by 2. And then check whether it's positive in this quadrant. No, so put a negative. The tan of 30 also, I can go ahead and divide this by this. I can divide sine theta by cosine to get the tangent, or I can just use SOHCAHTOA, and that will be 1 divided by root 3. 1 divided by root 3. Then I need to check whether tan is positive in this quadrant. It is not, so that will be negative. And again, since I don't want to write this with a radical in the denominator, I'll just write it as negative root 3 out of 3. Okay, I'll go faster on the next one. 5 pi out of 3. Remember, this is 180. 180 divided by 3 is 60. 60 times 5 is 300 degrees. So 300 degrees is over here. The reference angle is 60 degrees. Because if this is 300 and this is 360, the difference is 60 degrees. So it has the same ratios as 60 degrees. Go to the first quadrant. Ask yourself, what are the ratios of 60 degrees? The hypotenuse is 2. The opposite is root 3, and the adjacent is 1. So what are the ratios of 60 degrees? The sine of 60 degrees, that's going to be root 3 out of 2. The cosine of 60 is 1 out of 2. The tan is root 3 out of 1. But ask yourself, are tan, sine, cosine, and tan positive in this quadrant? Are they? All students take coffee. It's only cosine that's positive. The rest are negative. This is positive. Yeah, that's positive. Yeah, so this is kind of what we've been talking about. Right here you have 45 degrees. No, sorry. 30 degrees is the first one, yes. This is 30 degrees. This is 45 degrees. And this is 60 degrees. And the idea is that all the other angles in the different quadrants that have the same reference angle as these three will have the same exact ratios. So we can use that knowledge to solve a whole host of problems. This is giving us the x-coordinate and the y-coordinate. And I hope you can see that it's giving us the x-coordinate divided by the radius, which in that case is 2 units, y-coordinate divided by the radius, which is 2. Okay, sorry. This is a unit circle, yes, but it's, yeah, ignore me. This is just giving us a scale of the x and y coordinates in the first quadrant and expanding it out. You can see that 30 degrees is the same as pi out of 6, and its ratios are the cosine is root 3 out of 2, and the sine is 1 out of 2. Because the cosine is the x coordinate and the sine is the y coordinate. So that's cosine and sine. Cosine is the x coordinate, sine is the y coordinate. Okay, so what's the cosine of pi out of 3? Pi out of 3 is 180 divided by 3, which is 60 degrees. I can just go over here and read 60 degrees. The cosine is 1/2. 1/2. All right. What's the sine of pi out of 6? Pi out of 6 is 180 divided by 6, and the sine is the y coordinate. So therefore, the sine of pi out of 6 is 1/2. You can go back to this worksheet and practice to see if you remember what we did in that first lesson. So some examples. What's the reference angle for negative 170? Negative 170, remember, this side is positive, clockwise is negative. So I'm going to measure negative 170. Will be somewhere here, so close to 180, because this is negative 180 from that direction. So therefore, negative 170 is here, and the reference angle is the angle off of the x-axis, right? Please remember, we measure off of the x-axis, not the y-axis. This is not the reference angle. It has to be from the x-axis, which is this angle here. And I hope you can see that that angle is 10 degrees. So 170 degrees, negative 170 degrees, is going to have the same ratios as 10 degrees. Just need to look out for the ratios, the signs in each of the quadrants using this all students take coffee acronym. Find the reference angle, the quadrant of the terminal side, and the sine and cosine for 225. 225, first figure out which quadrant it is. It's not 270 because this is 270, and it's not 180, so it's in between 270 and 180, right? 225. First, find the reference angle, the angle of the x-axis. That's going to be this angle. From here, I can get it by subtracting 225, the reference angle. I can get it by subtracting 225 minus 180 degrees, which gives me 45. I hope we agree that it's 45. Yeah, 45 degrees. So the reference angle is 45 degrees. Okay. What else do I need to do? Find the quadrant of the terminal side. The terminal side is, because it was positive, the terminal side is this one. The quadrant of the terminal side is the third quadrant. Okay. And find the sine and cosine for 225. The sine for 225 will be the same as the sine of 45, will be the same as the sine of pi out of 4. So just go back to your unit circle and check what is the sine of pi out of 4. This one here. The sine is the x value, the y value, which is root 2 out of 2. And the cosine is also the same thing. So my sine of 225 has to equal root 2 out of 2. But I need to check, is sine positive in that quadrant? No, it is not. So that's negative. The cosine of 225 will be the same thing. Is it positive in that quadrant? No, it is negative. And what the other thing that can help you is if you look at the x value of this point, drawing it outside. If you look at the x value of this point, yeah, this x value is going in the negative direction, right? And since cosine is negative, since the x value is going in the negative direction and cosine is the x value, then you expect the cosine to be negative. If you look at the y value, this y value, right, up to here, it's also going in the negative direction. This is going in the negative direction. So you also expect the sign to be negative. However, the turn will be positive because you divide both of them. And dividing two negatives gives you a positive. The cosine of t is 1/7. T is in the fourth quadrant. Find the sine of t. So t is over here in this quadrant, right? So cosine is positive in that quadrant. That means sine and tan have to be negative in that quadrant. If this is t, then the cosine of t is 1 out of 7. Remember, cosine is adjacent divided by hypotenuse, 1 out of 7. So what is the sine of t? The sine of t will be equal to the opposite over hypotenuse from SOHCAHTOA. But I don't know what the opposite is. It's right here. I don't know what that x value is. I can use Pythagoras to find the opposite. If I use Pythagoras, then I can see that 1 squared plus x squared equals 7 squared. That means x alone is the square root of 49 minus 1, which is the square root of 48. So my sine of t will be square root of 48 divided by hypotenuse, which is 7. Is it positive or negative? I hope you can see that it is negative because it is in the fourth quadrant in which sine is negative. Find the coordinates of the point on a circle with radius 8 corresponding to the angle 7 pi divided by 4. Radius is 8. Okay. 7 pi divided by 4. What's that angle in degrees? Remember, pi is 180, so 180 divided by 4. Think of this as 180. It's being divided by 4, that's 45. And then what's 45 times 7? 45 times 7, that's big. Probably bigger than 360. 45 times 7 is 315. Wow, it's not bigger than 360. 315. So my angle that I'm looking for is 315. I expect 315 to be in this quadrant, right? In this quadrant. Right. If that's 360 and this is 315, then the difference is 360 minus 315. 45. Who knew? 45 degrees. Okay, so I expect 315 to have the same ratios as 45, but I need to take care of what is positive and what is negative. So the sine of 315 will also be equal to root 2 out of 2, but it's negative. What else? Find the coordinates of the point. Oh, okay. And the cosine will be equal to root 2 out of 2, which is positive. So the coordinates are the x value, which is the cosine, root 2 out of 2, and the y value, which is the sine, negative root 2 out of 2. I hope you can see that the x coordinate is positive because going in this direction to get to this point where that angle, makes a point of the circle is positive. The sign is negative because going down is negative. Evaluate sine 4 pi divided by 3 times cosine pi out of 2. Let's figure out what these angles are. 4 pi out of 3, this is 180 divided by 3 is 60 times 4 is 240. So I'm evaluating the sine of 240 negative times the cosine of pi out of 2 is 90 degrees. So do you remember what the cosine of 90 degrees is from our unit circle? Hope you guys remember that 90 degrees was here, up here, right? The x coordinate is the value of the cosine. The x coordinate for 90 degrees is 0, right? So I don't even need to care about what's happening in here, negative 240 degrees, because the x coordinate is 0, my answer is going to be 0. However, if this wasn't 0, because in your homework you might find questions where it's not 0. So what if, let's say this was sine, and this was cosine, right? Let's just say that. Let's say it was cosine 4 pi out of 3 times sine pi out of 2, and this is still negative. So I'm starting with a small one. Sine of 90 we know is 1, because remember from that circle, the y coordinate is 1. So this is 1. And I have to multiply that 1 by the cosine of negative 4 pi out of 3. Negative 4 pi out of 3 we have seen is the same as 240 degrees. So I'm looking for the cosine of negative 240 degrees. Step 1, figure out the reference angle. 240 is expected to be in here. If this is 240 and this is 270 and this is 180, the reference angle is 60 degrees, right? 60 degrees when if, oh sorry, that is not 240. That is not 240 because it's negative. Negative 240 is going like this. It's going to be in that quadrant because this is 180 negative and this is 0. This is negative 240 degrees, but the reference angle from negative 180 to negative 240 is still going to be 60 degrees. So figure out the ratios for 60 degrees. The cosine of 60 is 1 out of 2. I hope you remember that from that portion of the unit circle that you were shown. The cosine of 60 is 1 out of 2. But ask yourself, is that positive or negative in this quadrant, right? Cosine is always negative in this quadrant. What did I write? Take coffee. Cosine is always negative in this quadrant. So the cosine of negative 240 is going to be negative 1 out of 2. So my answer here is negative half times 1, which ends up being as negative 1/2. You will be required to do things like this without a calculator, so it helps to practice. You can verify your answer by writing the whole thing in a calculator, see if it gives you the same answer that you get from this deduction. Okay, this is your homework. I hope that's helpful. Yeah, bye.